Hi all, my name is Satrik Jaksono, and I will continue our previous discussion on the bending case, especially on how to find the natural axis. In some bending case, the natural axis is very obvious. The example is, as you can see in these three pictures, you can see that the upper part and the bottom part of all of these three things are symmetric. That's why the natural axis must be exactly in the middle. Unfortunately, not all the cases are like this. For cases as shown here, the natural axis is unfortunately not obvious. And like it or not, we have to find it first. We can solve the location of the natural axis by using this equation, where the location of the natural axis is equal to sigma y bar multiplied by A divided by sigma A, where A is the area of the composite part and y bar represents the distances of each composite part centroid to the x coordinate. Let us discuss one problem example together. In this particular case, we are asked to find out the natural axis of this particular shape. This particular shape can be divided into three composite parts. This is the first one, this is the second one, and this is the third one. And we must remember that the x-axis is at the top. Here, this is the x-axis. And how can we solve it? We can use the previous equation that we already discussed. Sigma y bar multiplied by A divided by sigma A. For this first composite part, the area is 250 millimeters times 20 millimeters. And the y bar there is the distance from the centroid of this particular composite part to the x-axis, which is at the top. And the distance there is supposed to be 20 millimeters divided by 2, which is the same as 10 millimeters. Then, for the second part and the third part, the area is 15 millimeters multiplied by 200 millimeters. And the y bar there is supposed to be the distance from the centroid of this part to the x-axis at the top, which is supposed to be half of the 200 millimeters, which is 100 millimeters. That's why we can find out that the location of the natural axis is 59.09 millimeters from the top. And if we have to calculate for the moment of inertia, we can do that as well. You can try it by yourself, and the results for this particular moment of inertia is supposed to be as shown here. I think that's all for this video. Thank you very much.